Well, hello friends. Today we are going to keep working on the browser, and since it is the very last day before the 1-year anniversary of the Serenity Git repository, then I figured I wanted to do something special. So today I'm going to implement the blink element in the browser, because I don't know why, it just seems like so appropriate. So let's do that. The first thing we're going to do is, I guess, just add a DOM interface for it. So that would be HTML, DOM, HTML blink element, CP and H, okay. And then we'll also edit the makefile. Okay, and finally I'll just update my Qt Creator files like that. And then let's just see that everything builds just fine. Yeah, okay, we're good. So let's go in the blink element, and maybe I guess we can actually just grab it from some other element just to get started. And then just, because we need this little boilerplate stuff. Because I'm not quite sure how I'm going to do this, but we'll figure something out. We'll figure it out as we go. Blink element. Blink element. Okay, and we don't need this gunk. So we just need the text inside of it to blink. And let's add it to the default CSS as well. So we'll do it'll be like a display inline. And I mean, I guess that's like the whole thing actually. And then we're gonna need to have a special behavior for this somehow. So I'm thinking, so we have two options here. We could create a special layout node that will implement this behavior in the layout tree, or we could let it just be a regular layout inline. So it would be a layout inline, which is already what you get if you open like a B tag or something like that. You will get a layout inline that has text children. So I think if we don't do a special layout node, but then we could instead drive the blinking from the DOM element, because we could go here and we could have a timer that like goes and pokes at the layout node and just changes its visibility or something like that. But none of these things exist yet, so we have to make them up as we go. I think we're just, for simplicity, we're just going to go with driving it from the DOM element. So we'll give this thing a timer. We'll use the C timer. And then I guess here we can say M timer. C timer construct, but I always forget what the heck the arguments are to C timer. So the core C timer interval and a callback, or just this one. Yeah, okay, let's just use the naked one. And actually then we can use a non-null ref footer. Okay, so we're constructing a timer, and then we'll say timer set interval. I don't even know what the heck the interval used to be. Was it 1 second? Let's do half seconds just to make it go a little faster. We can look up the specifics later. And timer on timeout. And then we're gonna want to do something. Then I guess we can. What are we gonna do? Maybe like blink. We'll have a private function here called blink, and we'll call that when the timer fires. Blink element, blink. Okay, if layout node. If there's no layout node, then just do nothing. But if we have one, okay, oh, we're gonna need okay, we get to the style. Okay, so it's const. So this is already a little bit weird because we've never mutated the style of a layout node before. And maybe we shouldn't touch the style of it, but we can have a special thing for this. We'll probably have to revisit this at some point or implement it somehow differently, but for now we can have a visibility state on layout nodes. So we'll have a is visible. This will just default to true. And then what we're going to do with this, typing and talking at the same time is difficult. What we're going to do with this is we are going to not paint anything or not render anything for this layout node if it's not visible, but it will be default visible. So visible. Oh, wow. Page down took me farther than I expected. True by default. Okay. And then in render, we'll say if is visible, continue. Oh, no, not continue, return. Right. So the idea here is that it's not the same as setting it to display none, because if you set display none, then we wouldn't create any. It wouldn't take up any space in the flow. But we want it to still take up the space. We just want it to not be painted for a moment until we want to paint it again. So let's try this. So set visible, not layout node visible. Is visible. How about that? Okay, and then we need to actually trigger a repaint. So how the heck are we going to do that? I guess maybe we can just say layout node. I'm tempted to use update because that's what I use in libgui, but like over time I grow less and less fond of the update name, and I keep wanting to switch it to set needs display. Like these are all the same thing, right? Like set needs display is I guess like the Coco way of saying it, and update is the cute way of saying it, and then repaint is the old WebKit way of saying it, and all of these are jumbled in my head. But I think this one is the most expressive, because update, that's very, very vague, right? It's a very overloaded term, but set needs display is kind of obvious. It's obvious enough. Whereas if you say repaint, it sounds to me like it's going to happen right away or synchronously, basically. But the idea here is that it might not happen right away, because otherwise it wouldn't be very optimized if every update is synchronous. So I think set needs display is a pretty good name. Or invalidate, actually. Invalidate is pretty good too. But set needs display is even better. Okay, so let's go with that for now. Set needs display. And what we're going to do in this little helpy function is set needs display. So we want to get to the HTML view. So all of the rendering is done by HTML view, which is a top-level G widget, and it contains a frame and a document and a layout tree. And it's this function here, the HTML view paint event, is what drives all of the painting in the browser right now. So in the paint event, we can see here that we set up the painter and blah, 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 and then we call layout root render, and then this will recursively render the entire tree. So what we want to do is basically trigger this, but ideally with a rect, a big enough, a rect so that we only repaint the layout node that actually changed. So the lazy version here would be to like redraw the whole page, but I think we can do better than that. So let's see. First we have to get to the HTML view, and we can get to the document, and then from there we can get to the frame. Let's see, auto frame. A frame is like a frame in the HTML sense. You know how you would have a frame set of frames, and then every page always has a main frame. So that's, I mean, we don't support frame sets yet, so it's only always just the main frame. And there should actually always be a frame, but we'll assert here anyway. In fact, maybe I should add a frame getter like this. I'll do that later. Let's not worry about that right now. So lib.html frame. So from the frame, we want to say set needs display. Then I want to pass it my coordinates, which would be my rect. Okay. And then, so my idea here is that an HTML view should have some sort of mechanism by which the frame can contact it. I'm not really exactly sure how that should work yet, but layout node is like very deep in the lib.html object hierarchy, and then we get out to the document, but we're still pretty deep because now we're in the DOM, and then we go to the frame, and the frame tree is like closer to the HTML view conceptually. So I think that's, we'll put that logic there for now, and then we'll work out some, we can do a better abstraction later. But we definitely want to get as far away from the layout node as possible, because that's very deep. Set needs display rect, and let's just add the rect file. Okay. So set needs display, and then we have a rect, and then we want to invalidate or update the HTML view. So for now, we can actually just set something like this up, or call this rect on set needs display. It's kind of cheesy, but I think that's maybe okay as a first version. Correct. Okay, and then in HTML view, where do we create the frame? New frame. Frame create here. Okay, so we have the main frame, and it's a member of the HTML view. So I think we can do this right here actually. Main frame dot on set needs display. Do this auto rect, and then and then this rect is going to be in content coordinates. So I'll say content rect, and then did I add a helper for this? To content position. Okay, well that's good enough. So then we can make adjusted rect is content rect, just direct and set location to content position, content rect dot location. It's a little bit awkward, but it's pretty good. I think that will adjust it. Wait, hold on. I'm doing it the other way around now. I want to go not to content position, I want to go to widget position. Crap. Okay, so I have to add one that goes the other way around. So there's widget coordinates and content coordinates, and this is a G-scrollable view, which is a widget that like has some amount of content inside of it that you can scroll it left and right, up and down, and then it sort of manages content coordinates versus widget coordinates. And now we just want to be able to convert between these. So, but I think it's pretty straightforward, because we just rename this to content position, and then we, oh dang, we rename this to that. Okay, and then we move it the inverse way. Yeah. So this is, it's really just accounting for the scroll bar positions and a little bit of offset that this 3D container sunken shadow thing looks. It's like 2 pixels of that. It's this frame that we set up here, actually. So to widget position. Okay, and then finally we should be able to update the adjusted rect. Okay, well, I forgot to write a test case, and I also needed to add this to the parser. So in HTML parser, we got to make sure that we find the blink tag and that we produce a blink element for it. Okay, and then, oh, let's do a test case as well. So base home and on dup welcome. First thing is we'll just add a little link here. Blink HTML. Or you know what? We can actually have something blinking right here. How about we make very simple browser blink? Wouldn't that be cute? I have no idea how this is going to go, but we'll find out. And that didn't build. Const frame blah 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 blah. Document frame is const, but what if I, oh, but I have a const document here. Okay, I'm just gonna be a little filthy here and do this, just so we can make progress. So I haven't really thought too much about constness when it comes to how I want the layout tree and the frame tree to interact. Like maybe I feel like maybe the frame tree should be non-const from the layout tree's perspective, because at the very least for set needs display to be able to work, unless we make it const in the frame. I'm not sure yet. We'll see. Other than that particular thing, maybe there's nothing else that a layout tree needs to mutate about the frame tree. So okay, well, it's definitely not blinking. I wonder if anything's happening at all. Let's see. Set needs display. Am I calling that? I am here. Okay. Set needs display rect, and then we would presumably have this We will presumably do this. Okay, so let's log this. Just to rect. Okay. And let's see what kind of rect we are sending to libgui for updates. Nah, nothing. Okay, well, that means that we are messing up way earlier. Are we even making a blink element, I wonder? Did I not start the timer? Oh, there we go. Okay. Oh shit, forgot to build. I think if we start the timer, it will probably work a little bit better. I can actually put that on a single line also. Alright, so now we are definitely doing the updates, but it looks not very good. So the rect that we are passing to update is bad. Let's figure out why. So it's using the rect for the layout node. So we're going to need to look at the layout tree to see what we ended up with. Let's make a little smaller test for this also. Body and blink. Hello, friends. Okay, and let's link to it. Let's copy that one because it almost says blink already. And then here, let's dump out the whole tree. So we'll dump out the layout tree. So let's look at the blink element. And we died. And what the heck? That's not what I wanted to see. Oh shit, this is the wrong dump function. That's what I want to dump. Okay, let's try that again. Blink. It actually dies. Set needs display uninitialized malloc memory. Well, that's not very good. Oh crap, I bet that we are not tearing down the tree correctly. Ugh. That's like a whole other kind of problem. Let's focus on one thing at a time here. I don't want to get carried away. So let me edit the welcome. Or no, let's automatically open a different file. Let's go to blink right away. Okay, so here is the layout tree that we are trying to paint. So these property IDs, I have to make something that prints out the property name. That's annoying. But anyway, we can find the layout inline. Here is the blink element layout inline, and it has 0 size and positioned at 0, 0. And the reason that this happens is because we've laid it out as part of inline layout, because text and layout inlines and stuff like that, they get laid out on a line, and wrapping at the end of the line and continuing and so on. And that works a bit differently than block layout. So here are the line boxes in the body block, and we can see here that Hello friends, this is the thing that's supposed to be blinking. It's this layout text right here, 999EE. And oh, we don't actually have the pointers, but we know that it says hello friends, so it's going to be this one inside the blink. But we want these metrics right here are the ones that we want. So I think the easy way to fix this is to have inline layout take the metrics that it computes and just give them to the layout inline. Although it is a little bit weird because that's not really what we want to do. What we want to do is we want to find all of, because we might be in more than one box, right? So we might not have a rect that corresponds to this blinking line, because imagine that you have something that blinks but it spans multiple lines. Then we want to repaint all of that. So what we should really be doing is iterating through all of the line box fragments that this layout inline has generated, and then invalidate all of them. Okay, so how do we do that? I guess that means that we have to find the containing block and then walk the line boxes looking for fragments that refer to this thing. So let's try that. HTML blink element set needs display, right? So here it's going to be a bit trickier. So I guess if is inline, then we have to do something hard. If it's not inline, then we can just do this and return. That's the easy way. But if it is inline, then we have to walk the line boxes. So we'll find our block first. So containing block, and then let's see, how do we do this? For block dot line boxes, line box, and then each line box has fragments in it. So for auto fragment and line box dot fragments, and then if fragment dot layout node, it's in reference, so we have to ampersand it. If it's this, or actually we can say if it's not this, we'll just continue. Okay, and now we know that this fragment refers to this layout node. Maybe it's a bit hard to understand what I mean by that, so I guess I can just show you some random page and oh shit, let me bring up the help app instead. So let's see here, for instance, this is one line box. Like one line of text is one line box. And even though all of this text here comes from the same text node and the same layout text object, it gets split up across multiple line boxes. So there are 4 line boxes here in this block. And right here actually is a layout inline that has like a fixed width font. It's barely visible, but it's a different font here. And so this line box has only one layout text on it, but then here's one layout text and then it ends, and then this is another layout text inside the fixed width font inline, and then we continue again with yet another layout text object over here. So each line box can have one or more layout nodes participating on it. So that's what we're iterating over here, and a fragment that's what I call these things. So This one has one fragment, whereas this one here has 3 fragments. It has this first fragment here, and then the access part is one fragment, and then yet another fragment. And each fragment refers to a layout node, and each fragment has metrics. And the metrics are what we're interested in now. So fragment rect, that's what we want. So we're just going to say, actually, yeah, we're going to do this. We'll pass fragment.rect to frame set needs display. Okay. That didn't do what I hoped for either. So let's see what we can work out here. Let's see, who is our containing block? If not inline, are we inline? We are inline. Containing block. And then we can do like a dump tree block. That will give us the layout tree starting at the containing block, just so we can see what we think the containing block is. So we are in line indeed, and the containing block is body, and then body has these. Oh crap! But it's not us. So right, so it's a layout text here. Right, so it's a layout text that's inside of us. So I'm asking, hey, is the fragment referring to this layout inline? But it's not. It's referring to this layout text that's inside of the layout inline. So I guess what we should be asking is, am I an ancestor? Am I the thing? Am I the fragment layout node, or am I one of its ancestors? So let's ask that instead. If it's me, let's see, or is ancestor of fragment layout node. I think that makes sense. So let's add a function like that. Is ancestor of if parent, I said ancestor. Let's call it ancestor. Parent member access into, what am I doing stupidly here? Oh, we don't know the signature. Or we don't have the definition of that class yet. We'll do it here at the bottom. Inline bool layout node. Okay. Then if ancestor is this, return true. Otherwise, no. False. Okay, we are in line. The containing block, blah, 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 and then update these metrics. They look very much like where we should be painting. The metrics look very good, I think. So let's get rid of that. Okay, and then Why you no worky though? Dun, 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 dun. Have a node is visible. Oh crap! Yeah, we're probably rendering it in some different way. Because render is virtual, so it's not enough to just go here in layout no render and do this visible return. We have to actually respect it in other places as well, which is a little bit awkward actually. Where the heck do we call render? We call render on the layout root, and then we call it recursively. Here we loop over all the node children, and that's so in layout block. This is why we're painting. Why the blink is not working, because in layout block we check if our children are in line, then we walk the line boxes, and then for each fragment we render that fragment. So this is why we're rendering. So the easy fix now is to just do this. So let's do that and just verify that everything else is good. I'll add it here as well to layout image just to be consistent. But I would like this to be at a different level somehow, but I think it's okay for now. We don't have to make a beautiful design on the first day. Okay, so why is it still not working? Update, let's see. That's here. We're still painting. Invisible is visible. Okay, and we're setting this. Oh, crap. Again, I'm forgetting about the line layout. So now we're just saying that the inline is not visible. So we have to go into the way that inline fragments or line box fragments are painted. So the is visible check that I added, it will work for renderers that draw themselves, so like block renderers or block layout nodes. But for things that are laid out in line, we still have to go, and I'll show you how that works. So in layout block, when we render a layout block, then we walk the inline children here, and then we call fragment.render on each fragment. And then what that does is, it's very, very simple right now. So it just checks that if it's a text layout node, then we cast it to a layout text and then call render fragment on it. And I think here we're going to need to do a visibility check on our ancestors. So maybe we can, let's see. Line box fragment. If layout node visible, but the layout node here is the text still, but like I'm thinking, I feel like when you set is visible, then it should become like all the children should become invisible as well, but maybe that doesn't make any sense. Maybe here we just have to walk up to the root, so let's just do that. Layout node parent. I need a helper for this, but this will be okay for now. Ancestor is visible. If it's not visible, then we'll return. Okay, Now, can you finally blink? You blinky blinky blink tag. Thank you. Dang it. Well, we have blink. Isn't it beautiful? I gotta look up what was the original blink rate. Blink element blink rate. Wait. How fast does it blink? I can't read this so fast. But here it says 250. So maybe 250 was it? But then here's 1 second. Blink. I don't know. I don't know what the answer is. Okay, let's just say that this was the right one. And because I don't wanna sit here all day looking for the right number. So let's just imagine that 500 milliseconds on, 500 milliseconds off. That's the rate. This is really cool now. We have a literal blink element. So let's see if we can improve it. If we refresh, then shit goes wrong because we don't tear down the tree properly. I'm not going to work on that in the video because it'll be some boring work, but I'll fix it afterwards. So let's try it out with some other thing. Oh, oops. Let's see. Let me add some H1 around it, see what happens. Look at that. We have a blinking H1. Very cool. And, oh, and what happens if it actually spans multiple lines? Both lines blink. Very, very cool. Very cool. What about if we blink? Hello there, my friends. What are you doing? Blink. It all blinks. And what if we span multiple lines? Look at it blink. Wow, that's really nifty. Maybe we can get an image to blink too. Shit, do we have any images that are cool? I guess we can just grab some from Res, wallpapers, or let's grab a smaller one actually. Icons. Why not serenity.png? PNG src that file res icons serenity png. Oh, look at it blink! Oh, that's so cool. God damn, that's awesome. So this has been kind of it was a little bit of a struggle bus right here, but I think we ended up in a decent enough place. So let's see what we can take out here. So in the libGUI, we changed scrollable widget to add a to-widget position, which is very helpful when you're converting from a content position to a widget position. So let's do that separately. libGUI add gscrollable widget to widget position. This is a complement to content position. Okay, that was unexciting, but nonetheless. And then let's undo these changes. Check out this change. And we don't want to change the default URL, which we had in there. And then let's look at the patch here. So first we added blink to the default style sheet just to make sure that it gets display inline. That's fine. And then when we call frame set needs display with a rect, then we fire this hook. So we just assume that the HTML view has set this hook before we get here. Okay, and then we're just adding this hook here to frame. And then here in HTML view, we set up the hook so that when we get a content rect that needs display, then we adjust it to widget coordinates, and then we tell libGUI to update that rect. That's fine. And then everywhere in the different layout render functions, we check is visible, and if so, we don't render anything. It's a little bit heavy-handed way of doing it. I would like to do it differently, but this will work for now. And then here we don't need the dump in layout node. Okay, so let's look at layout node set needs display. So currently it grabs the frame, and then if we are not an inline layout node, then we just use our rect, because if we're not inline, then we're a block, basically. We're a block or replaced something. And when we're a block, then we just have a rect. So it's fine to just pass the rect to set needs display, but if we are inline, things are more complicated and we have to find all of our rects. And this is how we do that. And this makes me think that we could have like a little helper that walks this, and like, let me do that. Let's see. For each line box fragment, let's see, for each line box fragment, that sounds like, I mean, I want line box fragments that refer to this layout node. For each fragment of this, let's say. I think that's pretty descriptive. And then we'll have it like that. And let's see how that would look. So there will be like for each fragment of this, let's templatize this. Callback. And then here we'll just do callback fragment. Okay. Because then we can write this code like this instead. Well, almost like that. For each fragment of this. Right. And then let's put this somewhere nicer. So in layout node, put that, but we'll actually implement it somewhere else. I think we'll implement in layoutblock.h so that we can access, so that we can actually access the definition of everything. Why is this so difficult? Sometimes I accidentally screw up my clipboard and totally ruin my workflow. But yeah, there we go. So now, since we're after the layout block definition, then we can actually reach into the layout block here and walk over the fragments. This is pretty neat. Although let's use an iteration decision here actually. So if it's iteration decision break, then we'll return from the whole thing. And then here we'll say iteration decision continue, because we want to walk all of them. This is just makes it possible to actually stop iterating if you should want to. Okay, that turned out pretty nice. Let's just see that it still works. Because my thinking with this is that if you then say that you implement some like optimized storage of your own fragments for some specific layout node, like for layout text, for instance, which very often ends up fragmented, then you could have a different storage and you can just overload this function to get that. But I don't know. Anyways, it's still pretty good the way that it is, assuming that it works, which it seems to do. Cool. So let's check that the blink thing still works actually. And look at that, we are blinking. Cool. So where were we? So here is for each fragment of this. And then down here is the layout node new stuff. So we have is visible, set needs display, is ancestor of. So I feel like this is ancestor of. Oh yeah, I had one of those actually. No, it's okay, we can leave it like that. For each fragment of this, blah, blah, blah. Here's the ancestor of. And then in linebox fragment, when we want to render a linebox fragment, we check if any of our ancestors are invisible. If so, we don't render. So this here, it's a bit sad that we have to do like a bottom-up walk of the tree every time we try to render a linebox fragment, just to check if it's visible. We could definitely do better here, but for now, this will work. Okay, and then we need to add the blink element. Blink. Actually, we can add that too. And I should have left that change in the welcome page just to link to it. We'll do it this way. Okay. So just in time for Serenity's first birthday, here is the HTML blink. It's the blink element. Let's see. This patch has a bunch of different mechanisms to enable partial repaints. Partial repaint of the layout tree. Then set its display. It also adds node is visible, which means that which can be toggled a layout from rendering, it still takes up space in the takes up space though. Yeah, it's pretty awesome. Okay, so I think that's going to be it for today's video. But let's see it one more time. So if you made it this far, then I thank you for watching, for hanging out, and for coming back and all of those things. I really appreciate it, and it's really fun to work on this. So thank you, everyone who stops by to check it out. And I guess happy birthday to Serenity. So thanks for hanging out. I'll see you next time. Bye.